Hello everyone. Today we'll see a 8051 program to convert a given ASCII number to BCD number. BCD is the binary coded decimal and the range of numbers is from 0 to 9. And ASCII is American Standard Code for Information Interchange and the range of numbers here is 30 to 39. So here this table it specifies ASCII numbers and the corresponding BCD numbers. Now, if we take the ASCII number as 35, its corresponding BCD number will be 5. So, here we'll take two numbers, that is 38 and 33. 38 is the ASCII of 8 and 33 is the ASCII of 3. If we look at these numbers, here if we subtract 30 from 38, we'll get 8, and if we subtract 30 from 33, we'll get 3. But here it's not like that. It is ASCII to packed BCD. It means that suppose we are given with two ASCII numbers that is 38 and 33. Here the first digit will be, that is here first we'll extract 8 from this 38, then we'll extract 3 from this 33, and we will swap this 8, that is 08, in order to get the MSB, that is 80. Then we'll add 03 with 80 to get 83. That is nothing but the 2-digit BCD number. Now we will see the logic. Here we are taking two BCD numbers, two ASCII numbers, that is 38 and 33, and the 2-digit BCD number for this will be 83. That is, here we want to extract 8 from 38 and 3 from 33. Now we'll take 38 and we need to perform masking here. We will mask the not interested bit, that is we are not interested in 3. So here we will unmask that and we want only what? We want only 8. So what we'll do is we'll perform a AND operation here, that is we will AND 38 with 0F. When we do this, we get 08. Okay, but we want 80 because here our MSB is 8. It means we want 80 here. We have 08. So what we have to do? We have to perform a swap operation here in order to get 80. Now we got the MSB. Okay, that is the most significant bit. We got it. Now we will take the second ASCII number, that is 33, and we want to mask this 3 here. Okay, so here what we'll do is we'll again AND it with 0F and we will get 03. Now here we don't need any swap operation because we want 03, which is the lower bit. Next is we want 83. We have 80, we have 3. We need to add these two. So in order to add these two, here these two can be ORed. 80 can be ORed with 03 to get 83. It is similar to addition. So here it is like 0, 0 is 0. This is a truth table for OR operation. So 0, 1 is 1, 1, 0 is 1, and 1, 1 is 0. So here we are performing a bitwise, that is logical bitwise OR operation we are doing. Okay, so it is performing bitwise logical OR operation. We'll get what? When we do this, we get 80 plus 3, that is 83. Now suppose here for this program we will take here we are assuming that we are storing our ASCII numbers from the memory locations 40H to 45H. Instead of converting only 2 ASCII numbers, we will take 3 ASCII numbers and convert it into 3 packed BCD numbers. Okay, so now here we are taking one ASCII number in 40H and 41H, another in 42H and 43H, and third number in 44H and 45H. So for 36 and 37, what we'll get? We will get the BCD number as 67, which should be stored in 50H memory location. For 39 and 34, we will get it as 94, which will be stored in 51H. And for 31 and 32, we will be getting 12, which will be stored in 52H. And here, so to get these, we have to repeat the process of taking the data, masking, swapping, and adding them 3 times. So here for this, we need to have a counter. Okay, for that we are taking R3 as the counter, and we will take R0 and R1 to point to the memory locations 40H and 50H. So here we are using R0 and R1 as the pointers to point to the memory locations 40H and 50H, and R3 is taken as the counter. We will see the program here. So in this program, it starts with ORG 00H, SJMP 30H, ORG 30H. Now these 3 instructions are taken in order to skip the interrupt vector table, or you can directly start with ORG 0000H. You can skip these 3 and directly you can take ORG 0000H. Now we will start with initializing the memory locations. For that we have taken move R0, #40H and move R1, #50H. This is for the, so here this is for to point to the source location, and this is for the destination location. Next we have taken R3 as a counter. So here we are taking 3 numbers. So for that we have written it as 03. Move R3, #03H. Next we have move A, at R0. So here we'll take our first ASCII number, that is 36, into the accumulator. Next we are supposed to add 36 with 0F. For that we have taken ANL, A, #0FH. ANL is nothing but the it will perform the bitwise logical AND operation. Now once it is done, so here we will get 6. Okay, that is we have taken A in we have taken 36 in A, we have ANDed it with 0F. So when it is ANDed with 0F, we'll get it as 06. Okay, we want 60. For that we need to swap. So when we swap A, that is when we swap the contents of the accumulator, this 06 will be changed to 60, that is 60. Okay, so the result becomes 60. Now we need to store this in 50H for further addition. So we will store it, and we need accumulator for ANL operation. So what we'll do is we will take this next instruction, that is move R4, A. Okay, so the contents of A, that is 60, these are stored in the R4. Now R4 consists of what? It stores 60. It is having 60. Next we have to increment R0. R0 was 40. Now it will be incremented to 41. Okay. So next number, first was 36 we have taken. Second number is 37. So now when this R0 is incremented, we will get it as 37. Now in the accumulator, the number is what? It is 37. So sorry, here when you increment it, increment R0, your memory location is pointing to 41H. Now the contents of 41H memory location should be copied to, or should be moved to, the accumulator. Now accumulator is having what? It is having 37. So this 37, it should be again ANDed with what? With 0F. Okay, when it is ANDed with 0F, so here we will get what? We will get it as 7. So now we don't perform an swap operation. Okay, we want it as 07 only. Next what we have to do? We have to add 07 with 60. 60 is in R4. That is, we have stored 60 in R4, and here the accumulator is having what? The accumulator is having 7 now. Accumulator is having 7. We need to add these two. So what we have to do? We will use a ORL A comma R4. That is, it will perform the bitwise logical OR operation. Okay. So here when we OR any number with 0, we get the same number. And here in the previous slide I have shown you the truth table for that. So next what you have to do, next is move at R1 comma A. That is, we have to store the contents of the accumulator at the location R1, that is at 50H. Okay, so move at R1 comma A. Contents of accumulator are stored in the memory location 50H. That is, R1 is now 50H. Next, again you have to increment R1. You have to increment R0. Okay, so when you increment R1, your R1 will point to the next memory location, that is 51H, and increment R0. R0 will point to the next memory location, that is 42H. Okay, and we have taken 3 numbers, so the next number will be in 42 and 43H. Okay, so that will be the second iteration, that is DJNZ R3 comma back. So back is where? Back is here. Okay, again it will perform all these operations, that is, it will perform and logical, and it will swap, then it will store that result in R4, it will increment R0, then again it will perform an ANL operation, that is bitwise AND operation, then it will add the contents and it will store in the next memory location, that is 51H, and it will continue this for all the 3 numbers until and unless this R3 counter becomes 0. Okay, then it will halt the program by this, that is, it will enter a infinite loop, that is H colon SJMP H, and it will end the program. So this was the logic behind the program. This was the explanation of the program. And here the input, we are taking it as 40H. At 40H memory location we are taking 36. 41H we are taking 37. Similarly up to 45H we are taking these all numbers, that is data. This is the first number, first ASCII number, second, third. So output should be what? Output should be 67, 94 and 12. That is 67, 94 and 12. Where? At 50H, 51H and 52H. So now we will see the execution of the program. I will copy the program from here first. Open the Keel software by double clicking on the icon. Go to project, new Vision project. You can create your own project, or you can use the previously used project. I will use the previous one, that is Alice. Save. Yes. Now here we'll search for 8089 C51. This is 8089 C51. Click on OK. So here click on No. Now go to the file, open new file and type your program here. I'll directly paste my program here and I will save it. Okay, what is this program? It is ASCII to BCD. So I'll save it as A to B. Okay, ASCII to BCD. Always you have to store your program with .asm extension. Save. Once you are done with this, go to the target. Right click on the source group 1. Click on add existing files to group source group 1. Okay. Now search for your program A to B.asm, add and close. Now go to project, click on build target. So here you are getting 0 errors and 0 warnings. Now go to debug. So start or stop debug session. Okay. Here we have to take 2 memory locations. Memory 1, it is I colon 40H where we'll give our input. And here we have to take memory 2, that is I colon 50H where we will see our output. Okay, so here what we have taken, the numbers 36, 37. I will write the same numbers, 36, 37. Then next is 39, 34, 39, 34. Then you have 31, 32, 31, 32. Okay, now we'll run our program. Go to debug, run. And in memory 2, we will get the answer, that is 67, 94 and 12. Here you can see. Just a minute. So the input is this, output should be 67, 94 and 12 in 50H, 51H and 52H memory locations. So here at 50, 51, 52H memory locations, we are getting 67, 94 and 12. So this was the program to convert the BCD number, ASCII number to BCD number. Hope you have understood the program. Thank you.